we have something slightly different? Say I have a toy rocket. Initially, I shoot it with an angle theta with initial velocity VO, but with an acceleration along that direction. When the condition given acceleration is along that direction, that means it's already overcome the G. So let's say we have a toy rocket, we shoot at initial velocity with an acceleration with such an angle for t seconds. So it will end up at B. So AB, how far it goes, that simply is VOT plus 1/2 AT squared. That's how far it goes. Let's define as distance D. We shoot a toy rocket with initial velocity, such acceleration, following such an angle. That means it's already overcome the gravitational acceleration for t seconds. So from A to B, in the t second, it's going to travel that distance D. It starts with y not meters above the ground. So therefore, if we know the D, then we moved this much of x, that much of y. The toy rocket strictly followed this path. So this angle, say this is a right angle triangle. So now where is the toy rocket? It is y naught plus y1 and x meters on the right side of where it starts, which is point A. So the toy rocket moved the position, plus at the end of the acceleration, the velocity here, VB, how do we describe VB? Well, since initial velocity and acceleration in the same direction along the line of AB, so VB simply follows that initial velocity plus AT, because V initial and A are same direction along this AB line. For t seconds, that is your VB. So that's VB. So this actually comes to as if we refer to the previous problem, now we start with a height of y naught plus y1, isn't it? This is how far away above the ground. See? Y naught plus y1. This is how far above the ground. That's capital H. With VB initial velocity. Now VB is equivalent to the V initial now. Angle theta still holds. So it just translates to a problem that capital H meters above the ground with such an initial velocity called VB with an angle theta with respect to horizontal. If we ask for what is the Y max, how long does it take to hit the ground? Well, we since already accelerate t seconds. Starting from here, we know the rest of it, and we can get a total. And what's the final? So we just need to, starting from B, and follow the previous example. We're pretty okay. So we need to learn one example thoroughly. Then later, if we have something similar, then we can relate to it, and we know what to do. Another problem. Let's say this is on the slope of a hill. Somebody do snowboarding and jump off with initial velocity VO, angle alpha. So it's going to follow this trajectory, right? Land around the slope. And the question is, if we want to maximize how far it lands, we want to land as far as we can. The question is, what is this angle alpha has to be? Theta is the angle of the slope. Well, the slope is not that straight, and maybe have surface, something like that. But if you connect that and with respect to horizontal, you get angle theta like this. So the question is, with a known takeoff speed and with a known slope angle, we want to maximize our what is alpha should be. How do we solve this problem? Well, probably you have no idea. When we have no idea, we start with basic. That will be VO sine alpha. This will be VO of cosine alpha, right? We split our initial velocity. And we know the y direction will encounter a g all the time. X direction is constant velocity. So starting from here, let's name point A, end up there at point B. The X direction, see, what happened is this is started from A, this end of B. Actually, it goes down. This is change of y. And goes to the right. That's change of x, right? See? This is how much change of y, change of x, and bring A as initial goes to B. So what happened is our delta x can be expressed as V initial of cosine alpha times the time. That's how long does it take to land, total time. How about delta y? Delta y. Delta y equals to, well, your initial y is that, you have a g. So delta y is initial time t plus 1/2 ay, that's negative g, t squared. Well, we are very short and delta y is negative. Why? Because, you see, it's going down. So that means the second term is very big. The negative term is big, so eventually the result delta y is negative. So, delta y is change of positions negative. So the absolute value of delta y is positive. Or we can negative this delta y, it becomes positive, right? Agree? Because delta y itself is negative. If we talk about this right angle triangle A, B, and this is C, isn't that true? Tangent of theta that equals to, this is the distance, it has to be negative delta y because delta y is negative after you had a negative times positive. That is delta x. So, this tells us we can actually combine this delta x and delta y. Why we need to combine it? Because as a matter of fact, what we're looking for, now look at this. If we want to max r, and then if we can max x, we max r. If we can max y, we max r. It's similar. So what we need to do is, if we replace that, we have this x and y combined with angle theta, and then we can use mathematics. We actually can max one of them, either max x or max y. Let's max x, and then we can find what is the angle alpha. Exactly how do we do that? Let's take a look. Now, if we have delta y equals to VO sine alpha t, from here we can get t equals to that delta x over VO cosine of alpha. So we're going to eliminate that t. So we have that delta y equal to VO sine alpha t. T will replace it with delta x over VO cosine alpha. And minus 1/2 gt squared, again, delta x of VO cosine of alpha, that's squared. And then we replace this delta y. Delta y is negative tangent theta delta x. You see that? So that is negative tangent theta delta x. So look at this equation. Left side has a delta x, right side, this is delta x, this is delta x squared term. So one of the delta x cancels. So this is the equation which has delta x and variable alpha. So if we want to max it, that is, we differentiate it. We differentiate this equation about delta x of alpha. We want to make it equal 0. That means ask what is the alpha makes our delta x max. When delta x is maxed, your slope r is maxed. That is the mathematical part of this problem.